Hi everybody, in this video we are going to present the Pythagorean identities and the quotient identities for trig functions. And let's start off with Pythagorean identities. Now these identities are based upon the fact that your standard angle when defined by a particular point actually forms a right triangle with one side being x, the other leg being y, and then the hypotenuse being r. And of course, since this is a right triangle, the Pythagorean theorem holds as it holds right here. So we can actually come up with three identities by dividing this equation either by x or by y, which we've done right here, or by r. Okay, I've divided it by y right here, and notice that when I do that, I have x over y squared, which happens to be cotangent squared, plus 1, and over here I have r over y, which happens to be cosecant squared. And that gives me this identity, which once again is this identity right here. I could also divide everything by x squared. That might make more sense. And if I do, I'm going to have 1 plus y over x squared is equal to r over x squared, and that becomes 1 plus tangent squared is equal to secant squared. Forgot my theta right here, okay, which of course is this one right here. And then finally, I can take x squared plus y squared is equal to r squared, divide everything by r squared, and that gives me x over y, r, not y, but r squared plus y over r squared is equal to 1, or cosine squared plus sine squared is equal to 1, which of course gives us this trig identity right here, which is the one that's probably used the absolute most. So do I want you to actually memorize these? Well, no, but I would hope that if you had to, you could figure them out once again by starting with the Pythagorean formula and then dividing appropriately by the variable that will make most sense to you given the problem that you have. Okay, the next set of identities are quotient identities, and this is based upon the fact that sine theta divided by cosine theta is actually equal to y over r divided by x over r. Okay, the r's will cancel, and you just simply have y over x, and you know what that is? That's right, that is tangent of theta. And of course the reciprocal holds. Since the cotangent is the reciprocal of tangent, cosine over sine gives you cotangent. So with those two identities, let's go over a couple of examples. Unfortunately, neither of these examples have anything to do with quotient identities, even though they are used a lot. Rather, here we are going to be focusing on the trigonomic identities. Now here we want to find cosine and tangent, given that sine is equal to the negative square root of 2 over 3, and that cosine is greater than 0. Okay, now, since cosine is greater than 0, and cosine is equal to x over r, when r is always greater than 0, this implies that x has to be positive. What can we glean from sine of theta? Well, we know that sine of theta is equal to y over r, okay? Which basically, once again, is equal to negative root 2 over 3. So any value of y over r that basically holds this proportion, we can work with. And one such combination of y and r is, okay, well, what about, let's let y be equal to negative square root of 2, and then r has to be equal to 3. Okay, we know this has to work out because r is always positive, so the sign is always going to go to y. So here we have y is equal to negative 2. we have r is equal to 3, and we know that x has to be greater than 0, and that's going to come in handy for us. Now we can go ahead and use the trig identity sine squared theta plus cosine squared theta is equal to 1 to figure out what cosine is, because cosine squared theta is going to be equal to 1 minus sine squared theta, which is going to be equal to 1 minus negative root 2 over 3 squared. Well, that is going to be 2/9. Negative root 2 squared is simply 2. 3 squared is 9. And this is going to be 1, or I can write this as 9 over 9, which means that cosine squared theta is going to be 7/9. If that's the case, then cosine theta is going to be the square root of this, which is going to be plus or minus the square root of 7 divided by the square root of 9, which happens to be 3. But remember, cosine of theta is positive, okay, so it's not going to be negative, and that gives us that cosine of theta is going to be the square root of 7 divided by 3. Okay, so now we know that y is equal to negative 2, r is equal to 3, and if that's the case, then x must be equal to the positive square root of 7. And from that, we can figure out what tangent is. Tangent of theta is going to be equal to y divided by x, all right? Negative root 2 divided by the square root of 7. We need to rationalize, so we're going to multiply up and top and bottom by the square root of 7. And that will give us negative square root of 14 divided by 7. And boom, there you are. You're done. Now for our last example, we have that the cotangent of theta is equal to negative 7 over 24, okay? And that theta is in quadrant 2. Okay, so here is my axis. This is where theta is, and that tells me that x has to be negative. Y must be positive. Okay, now remember, this right here is x over y. So any value of x over y, which has the ratio of negative 7/24, is going to be perfect. Okay, one such value combination is going to be where x is equal to 7, but since x has to be negative, we'll make it negative 7, and where y has to be equal to 24. Okay, so great. Now we know what x and y are, okay, and we know this is going to be in quadrant 2 because x is negative and y is positive. We now need to figure out what r is. Okay, well, from the Pythagorean theorem, r is going to be the square root of x squared plus y squared, and that's going to be the square root of 625, and the square root of 625 happens to be 25. Okay, so now we can figure out what sine is. Sine of theta is going to be y divided by r. What is y? Y is 24. And r is 25. There we go. Cosine of theta is going to be equal to x over r. Okay, what is x? X is negative 7. R is 25. And there's nothing to simplify because none of these fractions actually have common factors that are common in the numerator and denominator. So we are pretty much done. This will be our answer for sine. This will be our answer for cosine. And that is all I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Boyle.